Hello viewers, my name is Mr. Adebanjo. I want to strongly welcome you to this video. In this video, we are going to be discussing extensively on bearing and distance. This video is going to be a wonderful one, as many students have been clamoring for this video. They have been agitating for this video. They have been asking for this video. So I've come to fulfill their desires by explaining extensively on bearing and distance. So what are we going to be doing in this video? We are going to be telling you the principle that you need to know before you understand the bearing. We are going to be telling you, or we're going to be explaining to you the meaning of bearing, and we are going to be telling you the types of bearing that we have, and we are going to be telling you how you can locate the bearing on the cardinal points, and we are also going to be converting from one bearing to another. So we are going to teach you how to convert bearing from one type of bearing to the other type of bearing, and also we are going to be discussing on bearing of 2 points, how we can find bearing between 2 points, and also we are going to be discussing how we can find bearing between 3 points as well. And we are going to be extending all we have learned so far to solving past examination questions regarding 2 point and 3 point as well. So we have lot and lot of information regarding this topic for you. So I want you to sit back and enjoy and know how to solve bearing and distance. It's a long journey that we are going to engage together. We're going to be engaging ourselves one way or the other. So I want you to get your biro, get your writing materials, and sit down and with this material, and I believe you are going to understand the bearing and distance if you follow all the instruction that you are going to tell you in this video. There will not be any need for you to engage in any other class concerning bearing and distance if you follow all the principles we are going to be telling you in this video. But before we get started, please, if you are here to subscribe to this channel, please click on the subscribe button in the channel right now, so that you'll be the first person to know whenever we post information on this platform. And please share this video with students out there. There are a lot of students out there who need this material. They really need this video on the bearing and distance, so as to enable them to understand how to solve questions on bearing and distance. Bearing and distance is one of the important topic in mathematics, whether general mathematics or further mathematics. So you must understand it, and that's why we have brought this video to be able to enable you to understand bearing and distance. So the first thing you're going to be telling is the principle you must understand before you come for bearing. Before you understand bearing, or before you undergo the teaching of bearing, there are some things you must know or have understanding of before you even think of understanding bearing. Those principles are: the first one is you are supposed to understand Pythagoras theorem. You are supposed to understand Pythagoras theorem. If you don't understand Pythagoras theorem, please check my videos on this channel. You will see a video on a Pythagoras theorem where you can understand Pythagoras theorem. Also, you need to understand trigonometric ratio very well. So if you don't understand trigonometric ratio, so please visit my channel. You see a video on trigonometric ratio. You must also understand sine rule, then you must understand cosine rule as well. All these 4 principles you must understand if truly you want to be able to do justice to bearing. because when we interpret any question on bearing, we are going to use either of these either of these four principles to solve the question. So if you don't understand Pythagoras theorem, trigonometric ratio, sine rule and cosine rule, then you will have problem in bearing. And if you don't want to have problem in bearing, please, you must understand all these four principles, and all of them are already discussed on my channel. So you can find the video on each of these principle on my channel. So you must understand Pythagoras theorem, understand trigonometric ratio, understand sine rule, understand cosine rule. So having understood all those four principles, let's talk about what bearing is all about. What is bearing? The bearing of an object is the angle at which the object moves relatively to its position. So when we're talking about bearing, we are talking about an angle. Bearing simply means angle. We are looking for angle. We are looking for an angle. That is what bearing is talking about. So when we're talking about bearing, we are talking about angle that an object or a point make relatively to its position. So we are going to be discussing a lot when you're talking about bearing, you are discussing about angle. Bearing simply means angle, simple. So but the bearing is relative to the position of that object we are discussing, or we are finding its bearing. So that means without position there's nothing like a bearing. So there must be the object must have a position. The object must have a position before you can be thinking about this bearing as well. So, and like I said, bearing simply means angle. So when you're talking about, I ask you to find the bearing, they're asking you to find an angle. So when the question says find the bearing between such this point and the other point, definitely you are looking for an angle. So that's what bearing is. And also we also use the word direction. We use it in place of bearing sometimes. We use direction is used interchangeably for bearing. Sometimes instead of using bearing, we use direction as well. So these are the simple things you must understand before we go to bearing. So also in bearing, like I said, the angle we are looking for is relative to position. So any position of anything in bearing, we use cardinal point to represent the position of anything. So if you are looking for the bearing of anything, so the position of that thing is relative or is important, and we use cardinal point to represent the position of any object or anything. So and in cardinal points, this is a four cardinal point. This is the north, this is the south, west, and the east. You should be able to locate all these part of cardinal point: the north pole, the south pole, the west, and the east. So it's by drawing a vertical line, then you draw a horizontal line. So this one form a cardinal point, and it is cardinal point that we use to represent the position of any object or anything in bearing. So you're going to be seeing a lot of cardinal points in bearing. Having understand what bearing is all about and the position that we use your cardinal point to represent the position of an object in bearing, we have types of bearing that we need to know as well. We have two types of bearing that we must understand. The first one is compass bearing, which is also called the cardinal point, and we have three-digit bearing. So the first bearing we are going to be discussing in this video is compass bearing. The second one is three-digit bearing. So these two type of bearing we are going to discuss extensively in this video, and also how we can convert from compass to three digits and from three digits to compass bearing in case of objective question now. So let's start with compass bearing now. Compass bearing, another name for compass bearing is cardinal bearing. Another name for compass bearing is cardinal bearing. Now, like I said, this is a cardinal point, four cardinal points, and we use cardinal point to represent the position of an object or a thing in bearing. Am I communicating at all now? So in compass bearing, we are going to be talking about this cardinal. We are going to explain this cardinal point for you. Of course, we know that this is north, this is south, this is west, this is east. And in this cardinal point, we know that the angle between the north and the east is 90 degrees. Also here, between east and the south, the angle here is also 90 degrees. Between south and the west, there's 90 degrees. Between north and the west as well, there's 90 degrees. For the angles in 4 cardinal points as well. Then also we have 8 cardinal points. 8 cardinal points. And this is an example of 8 cardinal points. We have the north, the south, the west, and the east. Then we draw another line that should give us northwest. We are moving from the north to the west this way. North to the west, that gives us northwest. Then if I move from the north to the east, I have northeast. North to the east, I have northeast. That gives us this northeast. Then if I move from the south to the east, I have southeast here. And if I move from the south to the west, I have southwest as well. So this one gives us 8 cardinal points. 1, 2, 3, 4, 5, 6, 7, 8. So 8 cardinal points here. And we can see that between north and east here, the angle there is 90 degrees. What about between north and northeast? What is the angle that is there? The angle that is here is 45 degrees. So between north and northeast, the angle there is 45 degrees. That is, the bearing there is 45 degrees. Also between northeast and east, the angle there is also 45. Between south and the east as well, this 45 here, another 45 here, because the total angle here is 90. From here to here is also 90. So that means from the south to the east, southeast, the angle here is 45. Also here is 45. Then from the south to the west, southwest, the angle here is also 45. From here to here is also 45. From the north to the west, the angle here is also 45, and this is also 45. So there's a reason why I'm explaining this at this beginning of this question of this compass bearing, so that when we get to some stage in bearing, when we are using all these things, then you should know how it comes to be. So the other thing I want you to know in compass bearing is that when you are looking, we are talking about compass bearing. In compass bearing, there are 2 starting points in compass bearing. If you are looking, you want to make if you want to make the angle, or if you want to draw the angle of a compass bearing, there are 2 starting points. The first starting point is the north, and the second one is the south. For an example, if I have this vertical line crossed by this horizontal line, that means I have a cardinal point. Then I have the north, I have the south, I have the west, I have the east. Now in compass bearing, I want you to understand one thing, that there are 2 origin, or there are 2 starting points in making our angle. I can make angle from the north to the east. That should give us a northeast. The angle can be drawn from the north to the east. That gives us northeast. I cannot do it from east to the north. It is wrong. I want you to understand the first thing. I want you to understand that we cannot make the angle from the east to the north. No, it can only be from the north to the east. I can also make the angle from the north to the west, but I cannot do from west to the from the west to the north. So we can make the angle from the north, whether to the east or to the west. We can also draw the angle from the south as well. So from the south as well, whether to the east, that gives us the southeast. Also, we can also do it from the south to the west as well. That gives us a southwest as well. So there's something I want you to understand, that in compass bearing, the angle originates from the north, either to the east or to the west. It already also originates from the south, either to the east or to the what, to the west. So we have 2 origins in making the compass bearing. So I cannot go from the east to the south, wrong. I cannot go from the west to the south, it is wrong. I cannot go from the west to the north, it's wrong. I cannot go from east to the north, it's also wrong. But we can only move from the north to the east, that gives us northeast. I can move from the north to the west, that gives us northwest. I can move from south to the east, that gives us southeast. I can move from south to the west, that gives us southwest. I hope you understand. So okay, if you understand that, these are examples of compass bearings. All these examples are compass bearing. I have 30 degrees northeast. That means I'm moving from the north to the east 30 degrees. I have northwest, 48 degrees northwest. I'm moving 48 degrees from the north to the west. That is correct. 50 degrees southwest is an example of compass bearing. I'm moving 50 degrees south to the west. South to the west, 50 degrees. That is correct. I have 78 degrees, 78 degrees southeast. I'm moving 78 degrees south to the east. Is correct as well. Moving from the north to the west is correct. From the south to the east, correct. So these are examples of few examples of compass bearing. You can see that in compass bearing, all the angles are attached to are attached with the origin of the angle and where it ends. North to the east, north to the west, south to the west, south to the east, north to the west, and south to the east. So you can see that all the angles either originate from the north or originate from the what? From the south. We cannot do vice versa. You cannot change it. Are we there? Now, if you understand this, let's try to locate compass bearing on the compass. How can we locate compass bearing? Location of compass bearing. How do we locate compass bearing? Now that we know examples of compass bearing, how do we locate a compass bearing? Assuming I have a position with a compass bearing, how do I locate it? For example, I have 50 degrees northeast. I want to locate this now. How do I locate it? 50 degrees northeast. How do I locate it? Don't forget I told you that we use cardinal point to represent any point. So what do? You draw a cardinal point with your pencil and with your ruler. Don't draw cardinal point with a free hand. No, that will be wrong. Make sure you have a pencil and a ruler to draw a cardinal point. So let's say these are my own cardinal point now, north, south, west, east. And sometimes students don't know where the west and the east is. They are somehow confused. Don't be confused. This is the west, this is east. You need to get yourself acclimatized to that. So let's try to locate this bearing 50 degree northeast. This is north and this is east. They are moving 50 degrees. So what do? I will need to draw a straight line because I know that straight line will be here because I'm in the northeast. So I have to draw a straight line. Am I communicating? I draw a straight line. Normally you can measure this one with a protractor. So or sometimes you can, if you want to scale, you don't need to measure it with a protractor. So now draw a straight line with your ruler, and where will I put the angle? This angle 50 degrees, although I'm already in northeast, which is this from here to here. But where will I put the angle? Am I going to put the angle here, or I'm going to put the angle here? Where will I put the angle, here or here? The angle will be from the north to the east, so I'm going to put the angle here. So the angle will be, it will go from here to here, 50 degrees. So if you put it here, that means you are telling us you are moving from the east to the north, which is not valid in compass bearing. You cannot move from the east to the north. Rather, you can only move from the north to the what? To the east, 50 degrees. So you have been able to locate this bearing on the cardinal point like this. So that means this is the position of the object at this with this bearing. Let's see another one. I have a 70 degrees southeast. Let's locate this also. I will draw a cardinal point. Also, if I draw a cardinal point, then southeast. I'm moving from south to the east. South to the east. So that means I'm going to draw a straight line around here. So draw a straight line here. Then where am I going to put my angle? Here or here? I'm moving from the south to the east, so the angle is going to be from here to here like this. So you draw an angle from here to here, then you put your 70 degrees. So we have been able to locate this bearing 70 degrees southeast. We have been able to locate it like this. Let's see more question. I have 25 degrees northwest. How do we locate this as well? Draw your cardinal point like this. You can label it. If you don't label it, no problem. If you know where the north is, you know where south is, you know where the west is, and we know where east is. So what do? Where is the south? Northwest. Northwest is here. Northwest is here. So I will draw a straight line. So draw a straight line like that. Where am I going to put my angle? Here or here? the angle is going to be from the north to the west. So the angle is going to be here. We'll put the angle here. They are moving from the north to the west, then 25 degrees. So we have been able to locate this bearing like this. Also, let's see another one. We have 67 degrees southwest as well. So I will draw my cardinal point. You can see I did not label all the cardinal points here, so it doesn't matter. So far I know my south is here, I know my west is here. So I'm moving 67 degrees southwest. So south is and this is west. So I'll draw a straight line here. So I'm moving from the south to the west. So where will I put my angle? Here or here? So the angle should be here as well, 67 degrees. So this is how to locate a compass bearing on the cardinal point, or this is how to locate the compass bearing. Let's see one more example. You have a 100 degrees northeast. Is this bearing valid? It's a question I want to ask you. I want you to answer. Is this bearing valid? The answer is no. The answer is no. The bearing is not valid because you cannot move from the north to the east 100 degrees, knowing fully well that between north and the east, the angle there is what? Total angle there is 90 degrees. So this is more than the angle that the compass bearing can accommodate. So this bearing is not valid. So from the north to the east is 90. So you cannot see 100 degrees there. So it means that this bearing is valid. I purposely give you this so as to enlighten you the more that this kind of bearing, in compass bearing, the angle can always be from 1 degrees to 90 degrees. So you cannot have it to be up to 100 degrees. Yes, because from the north to the east here, rather, is 90 degrees. It cannot be up to 100 degrees. So when you get to this place, it's now from the south to the east, no longer from the north to the east. So 100 degrees northeast is not valid. So the bearing is what is wrong. I purposely gave you that. I hope you understand that. Okay, now if you understand what you have done recently, please try to locate the following compass bearing. Try to locate it. Draw the compass and the cardinal point for each of these, and locate each of these cardinal compass bearing, and locate them. I think I have 6 questions here to locate by yourself. This video and I will relate to that. Now that we understand what compass bearing is all about, now we can locate them. Let's go to 3-digit bearing. When it comes to 3-digit bearing, the bearing and the angles are represented in 3 digits. It's not like that of compass bearing, where we have where the angle start from and where it ends, not to the east, south to the east, not to the south to the west, or south to the west. No, in 3-digit bearing, we only have the angles in 3 digits. For examples, look at all these angles you have here. They are representing 3 digits bearing. You can see that no north, south is not added, no east is not added, west is not added to the angles. There are 3 digits, and you can see that all the digits here are 3 digits. So all the angles here are 3 digits, each of them. So these are example of a 3-digit bearing, and they should be able to differentiate between 3-digit bearing and compass bearing. So from here, like this, what can we see? In 3-digit bearing, the origin is always the north. In 3-digit bearing, the origin is always the north. The origin is the north. So The origin is not in 3-digit bearing. It's not like that of compass bearing. The origin is not in 3-digit bearing. In 3-digit bearing, the origin of the angle is the north. Very unlike that of compass bearing. You know, in compass bearing, we move from the north to the south, to the east, south to the west, north to the east, north to the west as well. The origin in the compass bearing is north or south, but in 3-digit bearing, the origin is only north. It's only what north, and we move clockwise direction. From the north, we move clockwise. So, if I have a cardinal point now, in 3-digit bearing, the origin is always north. It's always north. So, I move from the north like this, clockwise. So that's how to get the bearing of 3 digits. The origin is always north, only north, only north. So compares to that of compass bearing. Now let's see how we can locate 3 digits bearing. Example, I have 55 degrees to be located. Of course, I will draw my cardinal point as well. And also, another thing I want to know before we look at this is that when it comes to 3-digit bearing, from the north to the east here, you don't forget that the starting point is only north in 3-digit bearing. So from here to here is 90 degrees. From here to here is also 90. So that means from the north to the south, from here to here back here is 180 degrees. Then from the north to the west here is 270, and from the north back to the north is 360 degrees. So 90 plus 90 will give us 180, plus 90 will give us 270, plus 90 will give us 360 degrees. So let's look at this 55 degrees. Where will this angle fall? Will it fall here or here or here or here? Since we are moving from the north only, we cannot move from any other place. So where will this angle fall? It's going to fall in this point around here, because this one is from 0 to 90 degrees. So 55 will fall between 0 and 90 degrees. So what do? I will draw a straight line here, and where will I put the angle? The angle will be here, or the angle will be here. Don't forget the origin is north, so I'm going to draw the angle from here, from the north to this line. So I'll draw the angle from the north to the line, then I'll put my 55 degree here. So this is how to locate 3-digit bearing. Also, I have 110 degrees here. Let's try to locate that. I'll draw my cardinal point. Then where 110, where will it fall? Will it fall here or here? It's going to fall around here, because from here to here is 180. So, and from here to here is 90. And 110 is more than 90, so it's not going to be here. It's going to be around here. So I will draw my straight line here. Then where will I draw the angle? Will I draw the angle from here to here, or from here to here, or from the north to the line here? I'm going to draw it from the north to the line, because I already told you that when it comes to 3-digit bearing, the origin is always north. So you draw the angle from the north to the line here, and that will give us 110. Sorry, this is an error. 110 degrees, not 100 degrees. So let's see another question. I have 230 degrees. Let's try to locate that as well. When I draw my cardinal point, where will 230 fall? Will it fall here or here, or this point here? It's going to fall here, because this point here is 270 and this is 180. From 180 to 270, we have a 230 around that place. So 230 will fall around there. So I will draw a straight line here as well. Then where will I put my angle? Will it be from the north to this line, or from here to here, or from here to here? Where? It's going to be from the north to this point. So from the north to this point here, I will have that I'm going to put the angle, and that will give us 230 degrees. Don't forget, I'm trying to reference this angle. Whatever I put this angle I'm putting, you should know that I'm referencing this angle that I've marked here as 230. So I can put it here, I can put it here. I'm just trying to reference this angle here, or label it now. Let's see another angle here. Let's say I have 315 degrees. So I want to locate this angle as well. What do? Make a cardinal point as well. Then where will this 315 degrees, where will it fall? Here, here, or here? It's going to fall here, because here the angle here, stop at 270. and from 270 to what, 360. So 360, 15 will fall around here. So I will draw a straight line as well. Then how will I draw the angle? I'm going to draw it from the north to this line because this is a 3-digit bearing. So I will draw it like this. Then this is a 3-digit bearing from the north to this point. That will give us 015 degrees. So we can see also how we locate 3-digit bearing as well. They are quite very simple. How to locate the compass bearing and how to locate 3-digit bearing. They are quite very simple. So if you understand what you have just done now, please try to locate all these 3-digit bearing. Locate them and drop your answer in the comment section of this video, and I will use with that. So in the next thing we are going to be doing is how we can convert from compass bearing to 3-digit bearing, and how we can convert from 3-digit bearing to compass bearing. So we are going to see conversion of bearing from 3 digits to compass and from compass to 3 digits. This comes a lot in objective question, whether JAMB, NECO or WAEC. So they can ask to convert from one bearing to the other one. So let's see how you can convert from let's convert the following bearing to 3-digit bearing. We are giving all these bearing to be in compass bearing, so we are taking them to 3-digit bearing. The first one, we have 65° northeast. You want to take it to 3-digit bearing. Let's see how we do that. So this is 65° northeast. So how do I change this compass bearing to 3 digits? The first thing you need to do is to first of all locate this bearing on the cardinal point. Locate this bearing first, and I've taught you how to locate a compass bearing. Draw the cardinal point, and this 65 degrees will fall in northeast. Where is northeast? North to the east. So I will draw a straight line here. Then I'm moving from the north to the east 65 degrees. So I will have my angle from here to here 65 degrees. So that means I will have 65 degrees here. Do you understand now? So I've been able to locate this compass bearing. And don't forget, we are taking it to 3-digit bearing. And you know that in 3-digit bearing, the origin is always where? North. So I'm going to that means I'm looking for the angle from the north to this line as well. So from the north to this line, which is also was 65 degrees. So that means 65° north is same thing as 0.65 degrees. So if you convert 65° north is to 3-digit bearing, it's going to give us 0.65 degrees. Because if you locate this one, a cardinal point, we have this, and you are taking it to 3-digit bearing, the origin is also north. So you're going to move from the north to this point as well, to this line, and the angle there is what, 65. All you need to do is to add your 0 to it, and that gives us a 0.065 degrees in 3-digit bearing. Let's see 40 degrees northwest. So you have 40 degrees northwest. The first thing you need to do is to locate this bearing. So locate it on the cardinal point northwest. This is north to the west. So that means I'm going to draw a straight line here. So draw a straight line here. Then I'm moving from the north to the west. This is a compass bearing. So that means the angle is going to be from here to here, 40 degrees. So you have been able to locate this bearing now. Now I want to convert it to 3-digit bearing. In 3-digit bearing, where is the origin? The origin is what? North, back to this line here. So that means you are looking for the angle from the north back to this line here. So we are looking for the angle from the north to the line here. So that's what you are looking for, and that will give us the what you are looking for in 3-digit bearing. The question is, how do we get from here back to the north to this line? How do we get the angle from here to here? Since we know that from here to here is 40 degrees, and we know that from the north back to the north is also 360 degrees, then how do we get from here to here? All you need to do is to remove this 40, because this is what is left. This is what is left in the total angle here. So 40 degrees. So if you remove that 40 degrees from the 360, that should give us the remaining angle from here to here. So that means 40 degrees northwest is going to be equal to 360 degrees minus 40, and that should give us 320 degrees. Let's convert this 25 degrees southeast to 3-digit bearing. The first thing you need to do is to locate this bearing also. When you locate it, this is southeast, so that means you're going to have this south to the east. Draw a straight line there, then locate this angle from the south to the east. So from here to here, 25 what degrees. Then if you want to take it to 3-digit bearing, where is the angle you are looking for, or where is the angle going to start from? We'll start from the north to this line here. So we are looking for the angle from here to here. So that's what we are looking for in 3-digit bearing, because in 3-digit bearing, the angle is from the north. So from here to here, that's what we are looking for. Then how do we get that? If from here to here is 180 degrees, from the north to the south is 180 degrees, and from here to here is now 25, how do we get from here to here? I want you to answer that question. That means you are going to remove 25 from 180. That should give us from this, from whatever we have left here. So that means 25 degrees southeast will give us 180 minus 25 equals 155 degrees in 3-digit bearing. So that means this is equal to this in 3-digit bearing. Let's see another one. We have 15 degrees southwest. We want to take it to 3-digit bearing as well. The first thing is to do is to locate this bearing. This is 15 degrees southwest. This is south to the west. So I will draw a straight line here. When I draw a straight line here, I will locate this angle, and that will be from the south to the west. So the angle will be here from here to here. So the angle will be here. So then 15 degrees, and they want to convert it to 3-digit bearing. Where are we going to start the angle from? From the north to this line here. So from the north to the line here, that's what we are looking for. And how do we get that? It's quite simple. From here to here is 180 degrees, and from here to here is 15 degrees. So if you add 180 plus 15 degrees, that should give us what we are looking for. So that means 15 degrees south to west is the same thing as the 180 from here to here plus from here to here, which is 15, and that will give us 195 degrees in 3-digit bearing. You can see how we convert from compass to 3-digit bearing. So let's see how we can convert from how we can convert this 3-digit bearing to compass bearing. Now we have seen how we can convert from compass to 3 digits. Let's now see how we can convert from 3 digits to what? To compass bearing. The first thing we have here is 30 degrees in 3 digits. Let's see how we can convert it to compass. The first thing you need to do is to represent on a locate it also on the cardinal point. So draw a cardinal point also. This is a 3-digit bearing. That means the angle is going to fall around here. So because this is 30 goes to fall between 0 and 90 degrees, so 30 goes to fall here. So draw a straight line here like this. Then this 3-digit bearing, the angle is supposed to start from the north. So the angle is going to start from the north, then you have 30 degrees. Now you are taking it to compass, and in compass we will move from the north to the west, or from the north to the east, or from the south to the east, or south to the west. So in this case now we are looking for taking this one to compass, and we know that this line is here and the angle is here. So if you can move from the north to the east here, because you are finding the angle from here to here as well, that's what we are looking for. So we are moving from the north to the east. So technically 30 degrees, same thing as 30 degrees north to the what? To the east. 30 degrees 30 degrees, same thing as 30 degrees north to the east, since we are moving from the north to the east here to this line here. So that means you have been able to convert this 30 degrees from 3 digit to compass bearing. Do we understand what I've explained there? Since in compass bearing we are supposed to move from the north to the east here, so and we are going to cover the same angle we have here, which is 30. So all you need to do is to add the north to the east to this angle 30. That will give us it. That will convert it to compass bearing. Let's see this angle 130 degrees. Let's convert it to compass bearing. Now draw your coordinate point as well. Then this is 130 degrees in 3-digit bearing. Where will it fall? Where am I going to? Where would the line fall? Will it fall here, here, or here, or here? Since it is 3-digit bearing, it's going to fall here, because from here to here is 90, from here to here is 180. Sorry, from here to here is 180. So 90 stop here. 130 will fall between 90 and 180. So I'm going to draw a straight line here. Then I'm going to locate the angle. So the angle is from the north to this place. So I have from the north to this line. That gives us 190 degrees. So you are taking this angle now to compass bearing. Which angle are we looking for? Is it here, from here to here, or from here to here? In compass now, that means you are going to be looking for from the south to the east. So you are looking for the angle that is here, left here. So you are looking for the angle that is here. And how can we get that? That should be, from here to here is what, 180. So if you remove 130 from 180, that will give us what is left here. So that means 130 degrees is same thing as 180 minus 130, and that should give us the leftover here, which is 50 degrees. So 50 degrees south to the what? To the east. 50 degrees south to the what? To the east. Let's see the other ones. We have 245 degrees to be converted to compass bearing. How do we do that? First of all, locate this bearing as well. Draw your cardinal point. Where is this angle going to fall? It's going to fall around this point here. So draw a straight line to represent it. Then draw your angle from the north to this point, because this is a 3-digit bearing. So you have a 245 degrees. Then you have to change this one to compass bearing. Which angle are we looking for? Is it from here is it from the west to the south, or from the south to the west? You're looking for from the south to the west. So you're looking for from here to here. Then how do we get that? If we know that from here to here is 245, and we know that from the north to the south, from here to here is 180. So if you can remove 180 from 245, that will give us what is left here. From here to here is 180, and from here to here is 245. Remove 180 from 245, that will give us left over here. So technically 245 degrees will be equal to 245 minus 180, and that should give us 65 degrees from the south to the west. Let's see the last one. We are having 312 degrees. We have to convert it to compass bearing. Locate this bearing first. So draw your cardinal point like this. Then 312 is going to fall around here. Draw a straight line here. Then locate the angle, because this is a 3-digit bearing. That gives us from here to here 312. Then you have to take it to compass bearing. Which angle are we looking for? Are we looking from here to here? We are looking for from the north to the west. We are looking for from the north to the west. So how do we get that? It's quite simple. From the north back to the north is 360 degrees, and we have from here to here to be 312. If you remove 312 from 360 degrees, that will give us what is left here. So that means 312 degrees is same as 360 minus 312, and that will give us 48 degrees north to the west. So that is how to convert from 3 digits to compass bearing. Let's see some past questions that they have asked on this conversion of bearing. You have to express the true bearing of 250 degrees as a compass bearing. This bearing is 3-digit bearing, and they want us to take it to compass. How do we do that? Locate this bearing first. Draw your compass, and where with 254 is going to fall around here, because this 3-digit bearing. This is 90, from 90 to 180, from 180 to 270. So 250 is going to fall around there. So draw a straight line, then locate the angle. Angle is going to be from the north to this line here, because this is 3-digit bearing. So 250 degrees. And from there, if you want to take it to compass, which angle are we looking for in compass? Is it from here to here, or from here to here? It's going to be from the south to the west, because I told you the origin of the angles in compass bearing, from the south to the west. So we are looking for from here to here. And how do we get that? If from here to here is 250, and from the north to the south is 180, so we can get what is left over here by removing 180 from 250. So 250 degrees equals to 250 degrees minus 180, and that will give us a 70 degrees south to the west in compass bearing. So let's see another question, past question. We have to convert this bearing. The bearing 40 degrees southwest is same as what in 3 digits. So locate this bearing as well. Draw a cardinal point, and this is compass bearing. So this is in southwest. So this is south, this is west. So draw a straight line there. Then locate this angle south to the west. That will be from the south to the west. That will be 40 degrees. Then we are taking it to compass to three-digit bearing. That means the angle should be is supposed to be from the north down to this line here. So from the north to the line here, then that we are looking for from angle from the north to this line. How do we get that? It's very simple. From the north to the south is 180 degrees, and from here to here is 40. So 180 plus 40 will give us what we are looking for. So that means 40 degrees southwest, so it's going to be 180 plus 40, and that should give us a 220 degrees in three-digit bearing. You can see how we have been able to convert from three-digit to compass, from compass to three-digit as well, and vice versa in bearing. So engage yourself with all these simple things that we are doing in the on bearing right now, so that you get yourself used to them. So if you see them in the questions, you know what to do to them. So if you want to try them, you can try these 4 questions. Try to convert them as you have been asked to convert them. The first one, you have to take this 40 degrees southeast is same thing as what in 3 digits. And the second one, 50 degrees southwest is same thing as what in 3 digits. Then the third one is saying that 277 degrees is same thing as dash in compass bearing. The fourth one is 178 degrees is same thing as dash in compass bearing as well. Take your pencil, take your ruler, take a book and sketch all these things and convert it. Leave your answer in the comment section of this video and I will relate to them. Having understood this, let's now go to we are now going towards the real thing we want to learn in the bearing. Of course, everything you have been learning so far are very vital and important if truly you want to understand all these things we are going to be talking about now. So the first thing we want to talk about here, another thing we want to talk about is how we can find bearing in relation to 2 points now. Bearing in relation to 2 points. Now, what am I trying to say in essence now? Look at this question. We have the bearing of A from B is 60 degree northeast. You should know the type of bearing that this one is. So we have to, what is the bearing of B from A now? The bearing of A from B is this, and what is the bearing of B from A? So we're having 2 points now, point A or point B. And when we're talking about bearing of, in relation to 2 or more points, the word from is very important. The word from, it will tell you where you're going to start from, or which point you are going to start with now. So please take note of the word from. It's very important. The bearing of A from B, that means I'm going to start the bearing from what? From B. The bearing of A from B is this. So what do? I first of all locate point B, because we are going to start from B. Locate point B. And how do I locate point B? Is by drawing a cardinal point to represent point B. So I will draw a cardinal point and I will name it B. So this cardinal point now is representing point B now. Then the bearing of this A from B is 60 degree northeast, which is a compass bearing. So northeast is here, 60 degrees. So I will draw a straight line here. So you draw a straight line like this, then locate this angle. We have been doing how to locate angle in previous things we have done. So I'll locate the angle. I'll put my angle here. Since we know how to do that, then 60 degrees. So the bearing of what? A from this B. So we have located the bearing of the bearing, and we have located B. So the next thing you do is to locate what? Point A. So what do you do again? Whatever you can, this line here, we are not measuring it, just extend this to some extent. Then what do? Place your ruler here and draw another cardinal point. So draw another cardinal point to join to this line. Please don't bend your cardinal point. Some students are fond of bending it. Make sure that this vertical line is straight and this one is also straight like as well with your ruler to represent point what? Point A. I hope you can see this clearly. So this is point B, this is point A. So the bearing of this A from B is 60 degree northeast. That's what you're having here. The bearing of point A from B is 60 degrees north to the what? To the east. Then what is the bearing of B? What is the bearing of this B from A? Bearing of B from A. So we're now looking for the angle that this B make with what? A. So, and don't forget the angle given to you is a compass bearing. So that means the bearing you're going to get here is also going to be compass bearing. So you are given compass bearing here. So the bearing of B from A also is going to be compass. So that means which angle are we looking for? We are looking for the bearing of B from A. So can you locate the angle you are looking for in this point? That will give us the bearing of B from A. Don't forget the bearing is supposed to be compass, so not 3 digits. So that means the angle we are looking for is going to be, is it going to be from the west to the south, or from the south to the west? Since it is compass bearing, it's going to be from the south to the west. So you're looking for this angle here, from here to here. That is with the bearing of B from A, because it is compass bearing. But had it been it is 3-digit bearing, it's going to be from the north down to this line. I hope you understand what I'm trying to say. But it's because it is compass bearing, it's going to be from the south here to the west here. So we are looking for this angle here. Then how do we find the angle? Okay, it's very simple. The angle here, 60 degree here, is alternate to this angle here. So this angle here is 60 degrees. This angle here is going to be 60 degrees as well. Why? This line is parallel to this line. This west to the east is parallel to the west to the east as well. That makes this straight line a line of transversal. If you understand the parallel line in plane geometry very well, you understand what I'm trying to say here. So this is a parallel line, they are parallel, and this is a line of transversal. That means this angle here is alternate to this angle here. The angle that forms Z like this, it forms north with this, then with the south, so that forms Z. So Z, it forms Z rather. So you can see, then that means this angle here is alternate to this angle here. So if this angle is 60 degrees, this angle is also what? 60 degrees. The reason being that they are alternate what? Angles. So now that means the bearing of what? The bearing of B from A will be 60 degrees south to the what? To the west. 60 degrees south to the west. That's the bearing of B from what? A. Let's see another question. The bearing of point B from Q is 40 degrees southeast. What is the bearing of Q from P? And don't forget that the bearing given to us is also compass bearing. So, and where are we starting from? Are we starting from P or from Q? We are starting from Q. So draw a cardinal point to represent your point Q and label it point Q, then south to the east. So you draw a straight line like this, then locate this angle 40 degrees south to the east. It's going to be from south to the east 40 what degrees. Then join this line to point what? Point P. So place your ruler here, draw a straight line, and place your ruler here, draw a straight line to form another cardinal point for point what? P. Then having done that, we are now looking for the bearing of Q. This Q from where? From P. We are looking for the bearing of this Q from where? From P. So can you tell me the angle we are looking for? Don't forget the angle, the bearing given to you was compass bearing. So the answer you are going to get as well should be in compass bearing as well. So can you tell me the angle you are looking for? Are we looking for from here, or we are looking for here? We are looking for from the north to the west. That we are looking for, because it is a compass bearing. So we are looking for this angle that is here. That will be the bearing of Q from what? From P. Then how do we get it? If this angle here is 40 degrees, you should know that this angle here is also what? 40 degrees, because they are alternate what? Angles. They are alternate angle. Look at the Z. This is Z. This line, this straight line, and this line, this knot here. So that forms Z for us. So that's alternate angle. So therefore, the angle here is 40 degrees. Then from the north to the what? To the west. So that means the bearing of Q from P will be 40 degrees north to the what? To the west. But having B is it is a 3-digit bearing. That means the angle is going to be from the north back to this what? To the line here. Not like this. So I want you to realize we are going to be doing that very soon. Now let's see this bearing now. Or let's see this question. The bearing of M from N is 0.79 degrees. 0.79 degrees. And you look at that bearing is it is 3-digit bearing. It's not compass again. what is the bearing of n from M? So this bearing here is 3-digit bearing. It's not compass again. So you have to look for the bearing of n from M. So the bearing of M from N now. So we are starting from where? We are starting with N. So draw your cardinal point and label it N. So that means this position is for N, and the bearing of M from N is 79 degrees. This is 3-digit bearing, and in 3-digit bearing, the origin is from the what? The north, and 79 will fall in this point here. So draw a straight line to some extent and locate the angle from the north to this line, 79 what degrees. Then at this point, draw your another cardinal point to represent your point what? M. You label it M. Can you see clearly? So our aim is to now find the bearing of this N from M. Bearing of N from M. And the angle given to us is a 3-digit bearing. So can you tell me the angle we are looking for? The bearing of N from M. Where is the angle? We are looking from the angle from the north down to this point here. So you are looking from the angle from the north to this line here. Had it been it is a compass bearing, you know what you are looking for. You are going to be looking from the angle from here to here. That's what we will be looking for. But because it is 3-digit bearing, the origin of the angle in 3-digit bearing is the what? The north. So you draw it from the north to that line. So that will be the bearing of N from what? M. Do we understand that? Good. So if that is the case, how do we now find the angle from here back to this line here? It's very simple. From the north to the south here, what's the total angle that is here? From here back to here is 180. Then you can get from here to here. So you can get the angle from here to here, because this angle here is alternate to this angle here. So this angle here is going to be 79 degrees. So then from here to here is 180. Then 180 plus 79 will give us the bearing of N from M. So that means the bearing of N from M will be 180 from the north to the south plus the angle that we get there, which is 79, because it is alternate to this angle that is here. And that will give us 259 degrees as the bearing of N from M. Do we understand that? If the distance of A from B is 5 meters and the bearing of B from A is 127 degrees, what is the bearing of A from B? This is same thing as what you have done. It's just that they are adding the distance of A and B. In previous question, we are not giving the distance, so we are just extending the line to some extent. But now you are giving the distance to be 5 meters, so that does not change the question. Just that you are going to put the value of the distance between the 2 points here. So the distance of A and from B is 5 meters, and the bearing of B from A. So now I'm going to start with A. So draw a cardinal point to represent point A. Then label it A. Then the bearing is 127. Where 127? Where will it fall? Here or here? Because this is 3-digit bearing. Where will it fall? It's going to fall here. So I'm going to draw a straight line like this, and I'll put the distance, which is 5 meters. Then the bearing is what? 127 from the north to the line here, because this is 3-digit bearing. So 127 degrees. Then I will now draw another cardinal point to represent my point what? Point B, and I label it. Then the question wants us to find the bearing of A from where? From this B. The bearing of A from B. So that means, can you tell me the angle we are looking for, or where would the angle be? The bearing of A from B. Can you locate the angle by yourself? You can pause the video and try to locate the angle you are looking for. Because the bearing given to us is 3-digit bearing, so that means the angle you are looking for is going to be from the north back to this line here. So from the north back to this line, that we are looking for, that will be the bearing of A from what? From B. Do we understand that? Good. If you understand that, how do we now get the from here to here? It's quite simple. We can get the remaining angle that is here. You can get the remaining angle that is here. That will be 180 minus 127, and that should give us 53 degrees. And this angle here is alternate to the angle that is here. So angle 53 degree here is alternate to the angle that is here, remaining angle that is here as well. So that means this angle here is going to be 53 as well, because they are alternate angle. So if from the north back to the north is 360, and we are looking for from here to here, and we know that from here to here is 53, how do we get from here to here? It's very simple. That would be 360 degree minus 53. That will give us what we are looking for. So that means the bearing of point A from B is going to be 360 degrees minus 53. That gives us from here to here. That gives us 307 degrees. 307 what degrees. That's not the only way you can get that. From here, also, from another way is that I can find from here to here, from this point to this point, I can find this angle that is here from here to here. So how do I get that? If from here to here is 127, and I know from the north to the east here is 90 degrees. So if I remove 90 from the 127, that should give me 37 degrees. So that means from here to here is 37 degrees. That means the angle here is alternate to the angle that is from here to here. So from here to here is 37. That means from here to here is also 37 degrees, alternate what angle. So 37 plus this angle from here to this line here is 270. From the north back to here is 270. Then 270 plus 37. 270 plus this 37 here will give us 307 as well. So anyone you understand is still going to give us the same answer. So the two approach are the same thing. Let's see another question that could broaden our intellect on this bearing of 2 points. If the distance between this, if the distance of y from z is 10 kilometer, and the bearing of z from y is 258 degrees, what is the bearing of y from z? Very simple as well. We are starting from where? From y. The bearing of z from y is 258. So locate a cardinal, draw a cardinal point, and label it. Will you label it z or label it y? You label it y because we are starting from y. Then this bearing given to us 3-digit bearing. So where will it fall? Where with this angle, where will it fall? Will it fall here? No. Will it fall here? Yes. Because between north and this west, the total angle that here is from here to here is 270. So that means 250 will fall between 180 and 270. So it's going to, so I'm going to draw a straight line here, and we are given the distance from, which is what, 10 kilometers. So label it 10 kilometer. So when you label it 10 kilometer, then include the angle. The bearing given to is 258. So that means from the north to this place is 258 degrees. Then this locate your point z at this point here. Draw another cardinal point and label it what, point z. So we're now looking for what is the bearing of this y from z. Bearing of y from z. How do we get that? Bearing of y from z. Can you tell me the angle we are looking for? That being that the bearing is the 3-digit bearing. Can you tell me the angle we are looking for? Is it from here to here, or from here to here, or from here to here? The answer is from the north to this line here. So you're looking from the north to this line, and that's the bearing of y from z. And how can we get that? How can we get that? It's very, very simple. One way to get that is that from here to this west here is 270, and from here to here is 258. So if I remove that, if I remove 258 from 270, that will give us the angle that is here, isn't it? And that angle that is here will now be alternate to this angle that is here. And I know that from here to here is 90 degrees. So if I remove whatever I get here from 90, that will give us the bearing we are looking for. That's one way of getting it. Another way of getting it is that from here to here is 180. So, and from here to here is 258. If I remove 180 from 258, that will give me from here to here. That will give me from here to here. Now it will give me that. And that should give us 78 degrees. From the north to the south is 180. And from the north down to this place is 258 as we have been given. So, and I'm looking for this, for the angle that is here. If I remove 180 from 258, that will give me 78, which is from here to here. And that means 78 degrees is alternate to the angle that is here. The angle here is alternate to the angle that is here. This z is formed here, as you can see. That z is formed like that there. So this angle here is alternate to this angle that is here. So that means the bearing of y from z is going to be what, 78 degrees as well. So the bearing of y from z is 78 degrees, as you can see. So okay, we still have one more question. We're having the bearing of x from y is 300 degrees. What is the bearing of y from x? The bearing of x from y is 300 degrees. What is the bearing of y from x? So we are starting from what? Y. So you draw your bearing, you draw a cardinal point to represent point y, label it, then locate this bearing, which is 300. So that means 300 will fall at this point here. So draw a straight line there. And we are not giving the distance, so you don't need to put anything there. Then locate the angle. That will be from the angle from the north to this line. That will give us the 300 bearing. Then at this point, put another cardinal point there to represent your point what, x. So cardinal point is here, so your point x. Then we are now looking for the bearing of this y from x. We are looking for bearing of y from point what, x. Can you tell me the angle we are looking for? Yes, from the north to this line here. That's what we are looking for, because this is 3 degree bearing. Then how can we get the angle there? It's very simple. There are two ways we want to do it, but the fastest way is to get the angle that is here, the left over here, and that will be alternate to this angle that is here. So you can get the angle that is here, because from here back to the north is 360 degrees, and we are giving from here to be 300. That means this angle here should be 60 degrees. If you understand how we get that, remove 300 from 360 degrees, that gives us 60, and that means this angle here is alternate to the angle that is here, that will be 60 as well. So if from the south to the north is 180 degrees, and from here to here is 60, what will be from here to here? That should be 180 minus 60, and that should give us 120 degrees. So the bearing of point y from x is 120 degrees. So you can see how we have been able to find the bearing of 2 points now. The bearing between 2 points, how we have been able to do apply it, the bearing to solve the bearing between 2 points is very simple and straightforward. Whether the bearing given to you is 3 digits or the bearing given to you is compass, you should be able to relate with that. So if you understand what you have done so far, please try those 2 questions on the screen right now and see how you can relate with them, and drop you the answer in the comment section of this video, and I will answer you on that. Now we are now going to the crucial aspect of the bearing. Now the most crucial aspect of it is the bearing involving 3 points. Bearing involving 3 points. All those ones you have been doing so far, you can only see them in JAMB question or objective question of WAEC or NECO. Now we are going to the real part of the topic now, bearing, the theoretical part of it. You are going to be solving a lot of past questions, whether NECO, WAEC, in this part of the topic now. So I want you to sit back, take your pencil, and follow bumper to bumper how we are going to be solving those questions. And I'm going to be explaining it thoroughly, so that you will understand. They are very simple things you can relate with, I must tell you. Now the one you have done so far now, they are we have 2 point related, point A and point B, point P and Q, and so on. But here we are going to be having 3 point related. The first thing you want to see is that the one we are having on the screen right now. A village Y is 15 kilometers from point X on a bearing of 25 degrees. A village Y is 15 kilometers from a point X on a bearing of 25 degrees. It's very simple. So that means, where are you starting from? We're starting from village Y or point X. Don't forget, I've already told you that the word from will tell you where you're going to start from. You're going to start with what, X, on this bearing of what, 25 degrees, with what, Y. So what do? Draw a cardinal point, label it point X, then locate bearing of 25 degrees. That should fall in the first quadrant. Draw a straight line there and mark the angle out. So if I draw my cardinal point to represent my what, point X, then this bearing will fall at this around here, because this is a 3D bearing. It's going to fall from the north around here. So I will draw a straight line to represent the bearing. So, and then we have been given the distance, which is 15 kilometer, and the bearing is what, from the north to this line, 25 what degrees. Then at this point, what will I put here? I will put another what's it called, cardinal point to represent the village Y now, and I will label it village Y. So you have been able to represent this statement like this based on what you have been doing so far. But it does not end there. Let's see, another village Z is 20 kilometers from X on a bearing of 115 degrees. There's another village again, which is labeled Z, on is 20 kilometers from again, look at it, from where? X, from X, from X. So on the bearing of what? 115 degrees. So another village Z is 20 kilometers from point X. This same point X, another village is on this bearing, which is 115 degrees, and it's also 3D bearing. Where would this bearing fall? Will it fall here or here? It's going to fall here because it's 115 degrees, so it's more than 90 and it's below 180, so it's going to be around here. So I will draw a straight line again, but this straight line should be longer than this one because this is 20 kilometers, it's more than 15 kilometers. So take note of that. This line should be longer than this one. And whatever you are drawing here, please use your pencil and ruler. Don't use your free hand to draw this thing, so that I can give you a perfect shape. Use your ruler to join all this in together. So at this point X now, you draw a straight line here because 115 degrees will fall around here. So draw a straight line. Then the distance is 20 kilometers, which is longer than this one. Then mark the angle from the north to this line because it is 3D bearing. So the angle is going to be from the north to this line again because it is 3-digit what? Bearing. Then at this point, what will you do? Okay, you need to label this angle now. I've labeled it. I labeled this angle, this one that I marked, which is 115 degrees. Then at this point, you need to put village was Z. So put another cardinal point, then put label is Z. Then what will now happen? To form a triangle, you need to join this village Y to village Z with a straight line as well, with your ruler now. So join this to this point here. So if you join it, it will now give us a triangle like this. I hope you can see clearly. So you can now give us a triangle. Now this is where you need to remember your principle: Pythagoras theorem, trigonometric ratio, sine rule and cosine rule, because here you are going to be getting triangles, or when you are dealing with bearing and distance of 3 points, you are going to be getting triangles. And that is the reason why we ask you to go and learn all those principles, because you'll be applying one of those principles to solve each of the questions. Are we there now? You could apply 2 or more principles to solve each of these the triangle. But before we do go talk about that, this triangle now has 2 sides, 15 kilometer for XY and XZ is 20 kilometer, but there's no angle in the triangle. There's no angle here, there's no angle inside the triangle, there's no angle here. So we need to get an angle first. We need to get an angle first. How do we get out? Where can we get an angle? Can we get an angle here? Can we get an angle here? Or can we get an angle here? We cannot get any angle here, but we can get an angle at this point here because of the parameters given, this 25 degrees and this 115 degrees. So we should be able to get an angle inside the triangle. By now you should be able to tell me the angles we have in this triangle. Inside this triangle, you should be able to tell me the angle that's going to be there. If you want to try, you can pause this video and tell me the angle that will be here. Okay, let's see. If from the north here to this line here is 115 degrees, and from the north to this line here is 25 degrees, we are looking for from here to here. We are looking for from here to here. That should be whatever you have from here to the here minus whatever you have from here to here, because the angle you are looking for is from this point to this point here, which is inside the triangle. So you have 125 degrees minus 25. That will give us this angle here, and that will give us 90 degrees. So 115 degrees minus 25 should give us 90 degrees. So can you now tell me the name of this triangle? What type of triangle is this? Since this angle here is a right angle, since this angle here is a right angle, can you tell me the name of this triangle? That means a right angle what? Triangle. It's a right angle what? Triangle. So now that it's a right angle triangle, you should know the principle that you are going to apply to it. You can either apply trigonometric ratio or Pythagoras what? Theorem. You cannot apply sine rule, you cannot apply cosine rule here. Now, question asks us to calculate the distance yz. Distance yz. You have to look at this side. So, what can we use? We can use what? Pythagoras theorem. Since you are looking for only the side, you are not looking for angle. You can use Pythagoras what theorem. You're already given two sides. You can use find it, the third side using Pythagoras what theorem, because this is a right angle what? Triangle. And where is the hypotenuse side? That's the side that is facing the right angle, and that's the one we are looking for, yz. So can you formulate the Pythagoras theorem for us? That should be yz squared equals to sy squared plus xz squared. So that should give us yz squared equals to 15 squared plus 20 squared. Simplified it, that should give us 2225 plus 400. Add this together, that should give us oh sorry, there's an error here. This one is not part. This is 6. The answer is 225 plus 400. That's give us 625. Please, this is an error. This is a typographical error. It's not minus 600. There's nothing like there. So omit this one. The answer is 625. So you can just eliminate this step. Please eliminate this step. 225 plus 400 give us 625. Then our aim is to find yz. That means we need to find the square root of both sides. So square root of 625 give us 25, and the unit is in kilometer. So that means the distance between village Y and village Z is 25 kilometer. Please avoid this step here. It's an error. So let's see another question that can challenge us a little bit, still on bearing of 3 points. We have a hunter move 24 kilometers from a forest X on a bearing of 65 degrees. A hunter move 24 kilometers from a forest what X on this bearing. So draw a cardinal point to represent forest X. So I will draw a cardinal point and I put my forest what X on a bearing of what 65, and this is a 3-degree bearing. It's going to be around here. So draw my straight line, and this is what 24 kilometer, and then the bearing is what 65 degrees. I will locate that, then put my cardinal point here to represent where the hunter is currently. So this is where the hunter is currently after walking 25 kilometer at this direction, 65 degrees. So I'll put another cardinal point to represent where the hunter is currently. The hunter is here currently now, and thereafter 10 kilometer on the bearing of 115 degrees. So that means after the hunter gets here, it changes direction, it changes bearing to 115 degrees. Will it be here or here or here or here? That will be 115, will be around here. So that means I will draw another straight line, 10 kilometer, and you can see that one is shorter than this one. This one is 24, it's longer than the 10 kilometer. You should put all this one into consideration as well. Don't just draw anyhow. Are we there? Then 115 is 4 here. Then mark the angle from the north to the line here, because this is 3-degree bearing. Then put the angle here 115 degrees. Then what do? Put another cardinal point here to represent where the hunter is right now. So the hunter is going to be here right now after walking for 10 kilometers, and I can now label it the hunter, and I will now join this point to this where the hunter started from, the forest he started from. So label this point the hunter, or you can label it H to represent the hunter, then join this line to give us a triangle. So that is how to interpret the question. The question asks, what is the distance of the hunter from X? So that means this is where the hunter is right now, and this is point X. So we are looking for line side XH rather. We are looking for side SH. Then how do we solve that? We don't know the nature of this triangle. We don't know the name of the triangle. We only know that we have two sides given. We don't have any angle in the triangle. Then where can we get an angle? Can we get an angle here, here, or here? We can get an angle here. You can't get an angle here, you can't get an angle here, but you can get an angle here. How? If this angle is 65 degrees, then we should be able to know the angle that is here as well. What will it be? I want to ask you a question. What will it be? 65 as well. Reason being that they are alternate angle. This one forms Z, like this line, this straight line, and this line. So it's formed Z. That's alternate angle. So if this is 65 degrees, we can also get the angle from this south to this line here. You can get the remaining angle that is here. If from here to here is 155, and we know that from the north to the south is 180. So how do we get from here to here? We remove 155 from 180. That will give us the angle that is here, and that should give us what, 25 degrees. So that means the total angle that will be here from inside this triangle now, the total angle that will be here will be what? Will be 65 plus 25. That should give us what, 90 degrees as well. So that means the angle here is 90 degrees. So that means this triangle is also a right angle triangle. So, and we also find the distance of the ontap from the point X, which is the side of the triangle. So that means you can also use Pythagoras theorem since you are looking for side. And I want you to formulate the Pythagoras theorem for us using that diagram on the screen right now. Since you are looking for side SH, and that is the hypotenuse side because that's the side facing the right angle. So, excuse me. So that means we have a SH squared equals to HA squared equals to this side squared plus this side squared. So that should give us 576 plus 100. Add it together, 676. To find our SH, find the square root of both sides. That gives us a 26 kilometer as the distance between the forest X and the hunter. Alright, let's take it to another level. Let's see this Y pass question. Y is 60 kilometers away from X on a bearing of 135 degrees. So let's represent this one first. So Y is 60 kilometers away from X. So that means we are starting with what? X. So draw a cardinal point to represent your point X, and Y is on this bearing, which is 135, and it's a 3-degree bearing. That means the angle should be from the north. But where will this angle fall? Go to fall around this side here. So draw a straight line here, and the distance between X and Y is 60 kilometers. Put it there, and put the bearing there. That will be from the north to the line here to 135 degrees. Do you understand that? Then put your at this point here, draw your cardinal point to represent point what? Y. Also, Z is 80 kilometers from X on a bearing of 225. There's another point Z, 80 kilometers away from X on bearing of 225. Z is 80 kilometers away from X. From X. So where are we locating the bearing? We are locating on what? X, from this X again. And the bearing is what? 225. Where will 225 fall? Here or here? You go to 4 here because we are still working on X. You go to 4 here. So from the north down to the line. So we draw a line here, and it is what? 80 kilometers, which is going to be longer than this one. 80 kilometers. Then the bearing is what? 225. So make the bearing from the north down to that line, and that should be what? 225. Then at this point, what will you put there? You put point what? Point Z. So put a cardinal point to represent position of Z. Then use a line to join this together, and that form a triangle for us again. Are we there? Then the next thing is to find the distance between Z and Y, which is this side. Then we are not going to bearing now, but let's find the distance first. And we need to find the distance between this and this. We need to get an angle in the triangle. But where can we get an angle? Is it this angle here, here, or here? You can get it at X, so you can get it at this point. How? It's very simple. From here to here is 135, so that we can get the left over here. You can get the remaining angle that is here. If from here to here is 180 and from here to here is 135, so we can get from here to here. So that should give us 180 minus 135 give us 45 degrees. We can also get from the left over here as well. We can also get the angle that is here also. How? If from here back to this line here is 225, and we know that from this north to the south is 180, then we can get the left over here by removing 180 from 225, and that should also give us 45 degrees. That means total angle here will also be what? 90 degrees. 45 plus 45 here will give us 90, and that make this triangle also a right angle triangle. So we want to find side x and xy now. That means you can use Pythagoras theorem also, and that should be yz squared. Yz squared equals to this side square plus this side square. 80 square plus 60 square, that gives us 6,400 plus 3,600 equals to 10,000. Yz is going to be square root of 10,000, and that should give us 100 kilometers. That means this side is 100 kilometers. Are we there? Good. Now we are not going to the real part. Now we have been finding distance since. Now we want to dive into bearing. Bearing, we have to find bearing of z from y. Bearing of z from where? From y. Bearing of z from y. Bearing of z from y. Majority of the students can do, they can find distance, but when it comes to bearing, they are lost. And this one is a y-pass question. When they want to get bearing, they are lost, they are scared. Some of them will even use their height to gauge the angle. They say this is the angle. They will not even know, they don't know how to find it. But I will tell you, I will teach you how you can find all these things. They are very, very simple things. We are looking for the bearing of the bearing of z from y. So that means we are working on y. From y, we are working on y. And this is the line that join them together. This line join z and y together. So can you tell me the angle we are looking for? Since all the angle given to us, they are 3-degree bearing. So the bearing of z from y. Can you name the angle we are looking? Can you mark the angle for us? Mark the angle we are looking for. Mark it for us. Then we are looking for the angle from the north down to the z here. So we are looking, the bearing of z from the y is the angle from the north down to the line that join them together, which is this point. Do we understand that now? The bearing of z from the y is the angle from the north to this point here. The question is, how do we not get this angle now? That's the question we need to ask ourselves. How do we get this angle from here to here? It's very simple. Don't guess, please. Don't guess. Don't guess. We can bring it out. Now, from here, the angle that is here to from here to here, this left over here, we can get it. This angle here is relation to this angle 45 degree here. This angle here and this angle here, they are alternate. So this is the line, this and this. It forms Z. So this angle here and this angle here, they are alternate angles. So this angle is 45. So that means if you can find the angle that is left inside this triangle from here, from this blue line to this blue line, if you can find the angle that is there, if you can find this angle, then we'll be able to find the remaining angle that is here. Because if you add this one plus this one together and remove it from the 360 degrees, that will give us what you are from here to here. Do we understand that now? So we need to get the remaining angle inside this triangle. So we label it theta, so you can find it using this triangle. Do you understand that now? So if you not get that angle, then add it to 45 degrees, then remove it from 360 degrees. That will give us from here to here, which is the bearing of what we are looking for. So fine. If you understand that now, how do you find this theta? Then we can use trigonometric ratio, because this is a right angle triangle. We can use trigonometric ratio, and we have all the three sides given to us now. We have this side to be 100, so I can use opposite over hypotenuse, which is sine. I can use opposite over adjacent, because this is opposite of this angle theta, and this is adjacent of it. So opposite over adjacent, that will be tan. So let's see what we use here. Okay, we use tan. Tan theta equals to opposite, which is 80, over adjacent, which is 60. 80 divided by 60 will give us 1.3333. Then to find theta, that will give us a tan inverse of 1.33, that will give us 53 degrees approximately. So that means this angle here is 53 degrees. So therefore the bearing of z from y is equals to 360 degree, the whole angle here 360 degree, minus whatever I have here, minus whatever I got here. That will give us from here to here. So 360 degrees minus 53, which is what we got inside the triangle, minus 45 will give us 162 degrees as the bearing of Z from Y. Do we understand that? Good. Let's see another question that can challenge us a little bit. We have a point P is 40 kilometers away from Q on a bearing of 33 degrees. A point P is 40 kilometers away from Q. That means we are starting with what? Q. So draw a cardinal point to represent the position of Q, and this bearing, which is 33 degrees, is a 3-degree bearing, is going to fall at this point. So draw a straight line. Then the distance is 40 kilometers. Then the bearing, mark the bearing, which is 30 degrees. Then at this point, what will you have here? Make another cardinal point to represent your point what? Point P. So I make sure that your cardinal point is straight to join to this line, as you can see on the screen right now. So we have done that. Let's see the question again. Another point R is 65 kilometers from Q on a bearing of 125 degrees. There's another point R from where? From Q. From this Q, there's another point R on a bearing of 125. Where would that one fall? That will fall here. So I'm going to draw another straight line here. So another straight line will be here, which is 125 on bearing. So, and the distance is 65 kilometers, which is longer than this 40 kilometers rather. And the bearing is from the north to this line, which is what? 125 degrees. So label it like this. Then from there, then this point here will be point what? R. Put your cardinal point and target R. Then join P towards to R with a straight line. That form the triangle we are going to be working on. And we have to calculate the distance between P and R. Then we are looking for this side. And before we do that, we don't know the nature of this triangle. We don't know whether it's a right angle triangle or a non-right angle triangle. The only thing we can use to know that is by getting an angle inside the triangle, whether here or here or here. But we cannot get it from here and here. You can only get it from this angle here. And how do we do that? It's very simple. I think you have solved something like this before. We have solved something like this today. If from here to here is 125 and from here to here is 33, then how do we get the angle inside this triangle here? How do we get from here to here? If from here to here is 125 and from here to here is 33, how do we get from here to here? That should be 125 minus 33, and that should give us 92 degrees. 92 degrees. So that means this triangle is not a right angle triangle. The triangle there is not a right angle triangle because the angle there is an obtuse angle. It's more than 90. So that means we cannot use Pythagoras theorem and we cannot use trigonometric ratio. So that means we have back to sine rule and cosine rule. And if you have gone through sine rule and cosine rule, you should know which one you're going to use out of the two now, because we cannot use the two of them at the same time. So which one will work? Is it sine rule or cosine rule that will work with this triangle? We have these two sides given an included angle 92 degrees. We are looking for the side facing the angle. That means we cannot use a sine rule because we don't have a pair given. There's no complete pair given for us. So we can only use a cosine rule here now. If you want to understand this, please go through my video on sine rule and cosine rule. You will know the reason why we cannot use sine rule here, but we can use cosine rule. Now that we understand that, how do we use cosine rule here now to find this side? That will be the side PR squared. PR square will be equals to this side square plus this side square minus 2 multiplied by this side and this side, which is 2 times 65 times 40 cos the angle facing this side, which is 92. So we have cos 92. Then if you simplify that further, 65 square is 4225 plus 40 square is 1600. This time they give us 5200 cos 92. This plus this, then minus 5200 cos 92. If you simplify, if you press your calculator with this like this, calculator can simplify this one for you. That gives us 6006.477, which is the PR square. Then PR will now be square root of this, and that will give us a 78 kilometer approximately. So that means distance between P and R is 78 kilometer approximately. So, and that is that. Then the next question is to find the bearing of P from R. bearing of P from R, bearing of P from R, bearing of P from this R. Can you tell us the angle we are looking for? Can you mark the angle for us that we are looking for? That we are looking for the angle from the north here back to the line that join P and R together. So we are looking for the angle from here back to this line here. That's the bearing of P from R. That's the bearing of P from R. We are looking for the angle from the north back to this P here. And the question is, how do we get the angle? Like, how do we get the bearing? It's very simple as well. And I want you to follow me step by step as we do that. It's very simple. Now, we can get the angle that from here to here. And if you now get the angle inside this triangle, inside the triangle, this angle here, if you can get this angle here, and we get the angle here, and we now add it to the angle from the north down to this west here, which is 270. That will give us the bearing of what we are looking for. If I can get what is inside the triangle plus the angle that is here, plus from the north to the west here, that will give us 270, plus this will give us the bearing of what we are looking for. Is that correct? Yes. From the north to the west, this is 270. If you can get the angle here, and you can also get the angle inside the triangle, add everything together, will give us the bearing of P from what? R. Is that true? Yes. But the question is, how do we get the angle that is here? Good. Let's go here. We can find the angle from this line here, this east to this line. You can find the angle that is here from here. You can find it. It's possible. Is that correct? Yes. How can we find it? It's very simple. If from this line north to this line, this blue line here is 125, as you have been seeing here, and we know that from the north to this east is what's the angle from the north to the east is what? 90 degrees. Is that correct? From the north to the east 90, and from here to here is 125. So what will be from here to here? That should be 125 minus 90 degrees. That will give us the remaining small angle that is here, and that should give us 35 degrees. So the angle here is 35 degrees, being that 125 minus 33 degrees, minus 90 degrees, minus what? 90 degrees from the north to the east. From here to the here is 90 degrees. Remove it from the 125, that will give us 35 degrees. Then if this angle here is 35 degrees, that means this angle here is also what? 35 degrees. Reason being that they are alternate what? Angles. They are alternate what? Angles. So if this angle is 35 degrees, let's find the angle inside the triangle here from here to here. Let's find this from here to here. So let's call it theta. So we can find the angle here using what? Sine rule. Now you can use the sine rule to find this angle, because we now have a pair complete. Now we have this side to begin. We now have this side now, which is 78 degree, 78 kilometer, and we have the angle facing, which is 92 degrees. So then that is a pair. This angle and the side facing is a pair. We have it completely. Then the second pair, this side give the side this angle we are looking for. We have the side facing it. So that's another pair that we have halfway. So we cannot use it against this one that we have completely using sine rule. So that means we have sine of this. We are using sine rule. We have this side, which is 78, over sine of the angle facing, which is sine 92, equals to this side, because we are looking for this angle. So the side facing is 40. So we have 40 over sine of this angle, which is sine theta. From there, you can cross multiply. This time they will give us 78 sine theta equals to 40 times sine 92. Our aim to look for sine theta here, divide both sides by 78. That means we have sine theta equals to this divided by this. That gives us 0.5125. You press the calculator. To find theta, you find sine inverse of this. That should give us 31 degrees approximately. So now that if this angle here is 31 degrees, that means the bearing of P from R will be 270, which is from here to this west, from the north to the west, 270, plus 35, which is from here to here, plus 31, which is this theta. Don't forget that we are looking for the bearing from here to the line here. So that should give us 270 plus 35 plus 31. That gives us 336 degrees as the bearing of P from what? R. So I want to believe you understand. All these questions you have been solving, they are past questions, and they are very simple. Let's see this question also. A cyclist starts from point Y and rides 3 kilometers due west to point Y. A cyclist start from what? A point X. So locate point X with your cardinal point and ride 3 kilometers due west. Due west. Due west. This one you are not giving the bearing, but you are giving the direction. Where is the west of X? This is the west of X. So the cyclist move straight like this. He moves straight like this 3 kilometers to point what? Y. So at point Y as well, draw another cardinal point. That means the west of X will be joined to the east of what? Y. So you can see like this now. So the west of S is joining the east of Y. So a cyclist starts from point X and rides 3 kilometers due west to point what? Y. So it's supposed to be like this. Then at point Y here, he change direction, that is, he changes bearing and ride 5 kilometers northwest. From this Y now, he changes bearing and ride 5 kilometers north to the west. Northwest. Northwest. That is a compass bearing now. Northwest. So he moves north to the west 5 kilometers. Can we see that now? Northwest. That means you know the bearing, you should know the angle that is here. If it is northwest, you should know the angle that is here now. And you should know the angle that is here. That should be 45, 45, because this is a compass bearing now. North to the west. That means the angle here is 45. So they move from Y 5 kilo at it changes direction at and right 5 kilometers northwest to a point was Z. So that means you have another point here which is Z. So another cardinal point Z. Then you can now join Z to what? X. So join Z to X to form a triangle. How far is E from starting point? Where is the starting point? This is the starting point, and where the cyclist is now. So we have to find the how far is the cyclist, which is is here right now from the starting point, which is here. So we are looking for side XZ. Side what? XZ. And how do we get that? We need to get an angle in the triangle. No angle here, no angle here. There's no angle here. So, but we can get that. We should know that the angle here is 45 degrees because of the north to the east is a compass bearing 45 degrees. And also we should know that the angle between the north here and the east here should be 90 as well. From here to here is 90 degrees. So that means the total angle from here to here is what? 135 degrees. 90 plus 45 give us a 135 degrees. So that means we now know the nature of this triangle now, that this is not a right angle triangle. So if you want to find this side, then we are not going to use a trigonometric ratio. You are going to use sine rule or cosine rule. So which one are you going to use out of the two? Is it cosine rule or sine rule? You are going to use cosine rule. So if you use your cosine rule, you have a side xz squared equals to this side 5 squared plus 3 squared minus 2 into 5 times 3 cos the angle facing the side you are looking for, which is 135. Simplify this further. 25 plus 9. This time they give us 30 cos 135. Simplify this with your calculator. Don't press 25 plus, okay, 25 plus 9 will give us a 34. Then 34 minus, don't press 34 minus 30. That will be wrong because cos 135 is multiplying this 30. So we press 34 minus 30 cos 135 together, and it will give you 55.2132. Find the square root of both sides. We have a 7.43 kilometer, and if you approximate it to the nearest kilometer, we have 7 kilometer as the distance between this cyclist and the beginning of the cyclist. The cyclist is here, and this is the starting point of the cyclist. So then question says we should find the bearing of Z from X. The bearing of Z from X. The bearing of Z from X. So where are we working on? We are working on X. So can you mark the angle for us? We're looking for the angle from here to this line here. So from here to here, that's what we're looking for. That's the bearing of Z from X, from the north to the line that is joining them together. How do we get that? It's very simple. We know from the north to the line here, from to the west here is 270. Then if you can get whatever is left in the triangle from here to this, from the black to this black line. So if you can get that, add it to 270, that will give us what you are looking for. Then we can label this one theta. How can we get that? We can use sine rule to get that. So sine, we have this side which is 7.43 over sine of the angle facing it, because that's a pair. Sine 135 equals to this side, which is the side facing the angle we are looking for, 5 over sine theta. Cross multiply, we have this. Divide both sides by 7.43, we have sine theta equals to this. We simplify your calculator, we have 0.4758. Theta will be sine inverse of this, that gives us 28.4. So that means the bearing of z from x will be 270 plus this angle theta, which is 28.4, and that should give us 298.4 degrees to 1 decimal place as the bearing of z from x. Do we understand that? Let's see another question that can challenge us a little bit. A man set out to travel from A to C via B. So A, B, and A, B, C are talking about some places. All right, let's see what is the question says. From A, it travels a distance of 8 kilometers on a bearing of 30 degree northeast. So this is a compass bearing. It traveled from A now, so I will draw a cardinal point to represent point A, and on a bearing of 30 degrees northeast, like this. So this north, this is to the east, 30 degrees. I will draw a straight line. Then it is then I will measure put the angle, which is 30 degrees at the bearing. Now it's 30 degrees, and the distance is 8 kilometers to point what? To point B. So at this point I'll put my B there and label it by point B. Then from there, from B, it travel a further 6 kilometers. 6 kilometers due east. From B, it travel a further 6 kilometers due east. From this view now, it travel further 6 kilometers due east. Now this is point B. It travels 6 kilometers due east. Where is the east of B? Where is east of B? This is the east of B. So it move further 6 kilometers. And as you can see, you draw a straight line on the east of B, and it should not be long. It should not be as long as this 8 kilometers. Then you put another cardinal point here to represent your point C. So from B, travel a further 6 kilometers due what? East. So then what do you do now? You join C to what? To A, as you can see. Then the question says we should calculate how far C is north of A. Majority of the students here will find this question challenging, but it's very simple. Having done this now, how far calculate how far this C excuse me, C is north of A. C is north of A. How far is C north of A? Where is the north of A? North of A is anything from straight line like this. Don't forget that this line continues. I can continue this line like this. This north like this is still north of A. So C north of A. So this is C here, north of A. From C here to the north of A here to any point here. So I can extend this line here. I extend this line to meet the north of A. To meet this north of A here. So I can extend also this one as well. The north of A, I can extend it as well. So that means this is the distance of C from here to this place. Because anything from here like this up is the north of A. So distance of C from north of A is from here to here. Do you understand now? And this line we have extended will be perpendicular to this line, and that's one will give us a right angle here. So from here, all we need to do is to calculate the distance from here. So let's label this place B, D rather. Then we can find from here to here. Whatever we get from here to here, we now add it to 6 kilometers. That will give us the distance of C from the north of what? A. Then the question is, how can we find from here to here? We can see that triangle ADB is a right angle triangle, because it's a right angle here, and this angle here is a 30 degree, which is inside it, and this side is 8 kilometers. So we can use the trigonometric ratio here now to find this side, which is opposite over what? Hypotenuse. So sine 30 will give us from triangle ADB, we have sine 30 equals to BD over 8, opposite over what? Hypotenuse. Cross multiply, we have BD equals to sine 30 times what? 8, and if you multiply that, that gives us 4 kilometers. So that means from here to here is 4 kilometer. Add it to 6 kilometer. That should give us a 10 kilometer. So that means the distance of C from north of A is 10 kilometer. Then another question is calculate C east of A. Calculate this C east of A. Where is the east of A? This is A here, and this is the east of A. So I can extend this line also. I will extend this line, and I will extend my line of C as well. So if I extend this C here to the east of A, I will extend this C here to the east of A though. So the east of A is also like this, continue like this. So they will meet at this point. So I'm looking from here C to this point here. So I can call this point E. So I'm looking for CE. I'm looking for sign CE. That's the distance of C from what east of what A. Because this is any point here is the east of what A. So how can we do that? It's very simple as well. See, this is a rectangle. Consider it's a rectangle. So that means this side should be equal to this side. So if I can find my AD here, that should be equal to my CE as well. So I can use this triangle also to find my AD. So from triangle ADB as well, you can use a trigonometry ratio as well to find this side. You use cos. Cos is adjacent over hypotenuse. So that will be our AD over 8. Our AD is what we are looking for. We want to find our AD, so that's what is equal to this CE. So if you cross multiply from here, you have AD to be equal to 8 times cos 30. If you simplify that, give us 6.8, 6.9 kilometer. So if AD is 6.9, that means C is also 6.9. So that means the C is 6.9 east of what A. So C is 6.9 east of A. So that means from here to here is 6.9. Are we there? Good. The last one here, you have to calculate the distance AC. You have to calculate from here to here. Distance AC, you have to calculate next. How do we do that? That means you need to use triangle ABC. This non-right angle triangle, we have to use this triangle to find that. And how do we do that? We need to get an angle inside the triangle. There's no angle yet, apparently. So how do we do that? You can get an angle here. That angle here is alternate to this angle here. That will be 30 degrees. And we should know that this line here and this west and sorry, this east here and the south here, they are perpendicular. That means the angle here should be 90 degrees. So that means the total angle here should be 120 degrees. 130 plus 9 will be 120 degrees. So we have this side given, you have this side given, we are looking for this side, so you can use a cosine rule as well to find this our side AC. So if you use cosine rule from triangle ABC, using cosine rule, we have AC square equals to 8 square plus 6 square minus 2 into 8 times 6 cos 120. If you simplify, you have 64 plus 36. 2 times 8 times 6 give us 96 cos 120. Simplify it, that gives us 148. Then to find our AC, find the square root of 148, and that will give us 12.2 kilometer as the distance between A and what C. As the distance between A, C. So that's the solution to that question. It's a challenging question, but I must tell you that it's a simple question if you follow it step by step. All right, let's see another question. As you can see on the screen right now, the bearing of Q from P is 150 degrees, and the bearing of P from R is 15 degrees. I must tell you that this question, if care is not taken, majority of the students may fail the question. If they may make mistake in the question, because the question is somehow a little bit challenging. Let's see. The bearing of Q from P is 150 degrees. So I'm starting with P. So I'll draw a cardinal point for my P, and at the 150 degrees. So that will fall here. Draw a straight line, and then allocate my Q. Then the bearing is 150 degrees. Locate that, and this is a point Q. So the bearing of Q from P is 150 degrees. That is done. And the bearing of P from R is 15 degrees. The bearing of P from R, the bearing of P from R. Bearing of P from R. I want you to digest that statement. Bearing of P from R is 15 degrees. Where will I put my R? Will I put it here? Will I put it here? Will I put it here? Bearing of P, this P here, the bearing of it from R. So where am I going to put my R? Here to this place or here to this place? So if I put it here, then 15 degrees is supposed to be around the first corner here, around the first corner. When I draw the cardinal, it's supposed to be around the first corner here, 15 degrees. So if I put the location of R here, that line will not join to that point. But if I put it here now, if I put my R here, then 15 degrees here will fall here, and I will be able to join it to P. So I will join this line to the P here, and the 15 degrees will come out. So the bearing of P from this R is 15 degrees. So that means our R will be here. Then from there I can join this R to Q. Then also we are told that if Q and R are 24 kilometer and 32 kilometer respectively from P, Q is 24 kilometer from P, so that means this side will be 24 kilometer. Then R is 32 kilometer from P, that means this side will be what? 32 kilometer as well. So we have to find the distance QR, which is this side. But before we can do that, we need to get an angle in the triangle. And where do you think we can get it? We can get it here. How? This angle here is alternate to this angle here. So, and if this angle here is 150, we can get the remaining angle that is here. So from here to here is 180. That means this angle here should be 30 degrees. And this angle here should be 15 degrees as well. Alternate angle. Total angle here should be what? 45 degrees. So to find this side now, we use what? Cosine rule. So we use cosine rule to find side QR. Seeing what you have on the board on the screen right now, you have QR squared equals to 32 squared plus 24 squared minus 2 into 32 times 24 cos 45. Simplify that, you have your QR to be 22.7 kilometer. Then you have to find the bearing of R from Q. 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 Can you tell me the angle we are looking for from the north to the line that join them together? So we are looking for from the north to this line here. That's the angle we are looking for. How can we find it? Very simple. You can get the angle that is here. Since this angle here is 30, that means the angle here is also 30 degrees, alternate angle. So you can find the remaining angle inside the triangle. So you can call that on theta. Then this plus this, you remove it from 360 degrees. You give us from here to here. Do you understand that? Good. So how can we find this angle here? Can use sine rule. Since we have a pair completely now, this angle is given. We have this side facing it, which is 22.7. So that means we have 22.7 over sine 45 equals to the side that is facing the angle we are looking for, which is 32 over sine theta. Cross multiply. We have this. Divide both sides by 22.7. We have sine theta equals to this. Divide this with your calculator. We have 0.9968. To find theta, find the sine inverse of 0.9968, that gives us 85.4. Therefore, the bearing of R from Q will be 360 degrees, which is from here back to the north, minus the angle you get here, which is 85.54, minus 30 degrees. That should give us 244.6 degrees as the bearing of R from Q. All right, we are getting there. Another question. 3 point P, Q, and R are on a horizontal plane. Point Q is on bearing 120 degrees, and at a distance 80 meters from P. Point R is on bearing of 45 degrees and distance 150 meters from. So let's try to simplify the question from the beginning. So we have 3 points on a horizontal plane. Point Q is on a bearing of 120 degrees at a distance of this from P. So I will start with my P. At this bearing, 120 will fall here. Draw my straight line here. Then bearing 120 degrees is there, so I label that 120. Then I'll put another point here. Okay, we are given the distance, which is 80 meters, will be here, and that means I'll have point what? Q here. So cardinal point to represent Q. Also from point R is on a bearing of 45 degrees at a distance of 150 meters from where? From Q. From this Q, there's a point R. So on a bearing of 45 degrees. So from Q here, bearing of 45, 45 will fall here. So I will draw a straight line as well, which should be longer than this one because this is 150 meters. So the bearing is 45 degrees. I put that here. Then another point should be here, which is point R with a coordinate point. Then the distance is 150 meters. Then I will join R to what? To P. As you can see, so we have the triangle like that. Very simple. So we have to find the distance PR, which is from here to here. And how do we do that? Unless we have an angle inside the triangle. Then we can get an angle here. How can we get that? We already have 45 degrees inside the triangle. So from here, if from here to here is 120, we can find the remaining angle that is here because that angle is alternate to the angle that is here. So we can find the angle that is here. So that will give us 180 minus 120. That will give us a 60 degrees. So this 60 is alternate to the angle that is here, and that angle is 60 degrees. So that means the total angle here will be 105 degrees if you add them together, 60 plus 45. So that made this angle a non-right angle triangle, which means you can use cosine rule to find this side. So if you apply a cosine rule, we have a side PR squared equals to 150 squared plus 80 squared minus 2 into 150 times 80 equals 105. Then from there, this squared will give us 22500 square plus 80 squared give us 6400. Multiply this, you have 24,000 cos 105. Simplify this, you have a 35,111.657. Find the square root of both sides. We have a side P how to be 187.4 meters. So this side is 187.4 meters. So we have to find the bearing of P from R. Bearing of P from this R here. Bearing of P from R. So that means we are working on R, and we are looking for the angle from the R, from the knot to the line that join them together. So we are looking from the knot to this line here. That's what we are looking for. And how can we get that? It's very simple. We know that from here to north, from the north to the south is 180, and you can get the angle from here to here. We can get it. No, and we now get the remaining angle inside the triangle. That will solve our problem. You add them together. So you can get the angle here, and the angle here is alternate to the angle that is here, and that should give us what? 45 degrees. So we can get the angle inside the triangle, call it theta. We use sine rule to find that. So that will be this side we have gotten over the sine of the angle facing it. That's a pair equals to the side of angle we are looking for, the side that's opposite the angle we are looking for, which is 80 over sine of the angle theta. Cross multiply, we have a 187.4 sine theta equals to 80 times sine 105. Divide both that by 187.4. That gives us sine theta to be 0.4123. Theta will be sine inverse of this. That gives us 24.4 degrees. Then from there, that means this angle here is 24.4. Then the bearing is from here to the line here. That will be 180 to here plus 45 plus whatever we got here. That should be 180 plus 45 plus 24.4. And that should give us 249.4 degrees. Then let's look at the last question here. How far west of R is Q? How far west of R is Q? Where is the west of R? West of R, this is R, is west of R is around here. This is the west of R. So how far west of R is Q? This Q. So that means I should get a line that should extend the west of R, then join it to the Q like this, join it to this Q. So that means I'm looking for from here to here. So I can label that on T. So that will give us a right angle what triangle. And this angle here, we already know the angle inside the triangle. The angle, we already know this angle here, which is 45 degrees. So we can use that to find from here to here as TR, as how far R is from what Q. How far west of R is what Q. So we can use opposite over what hypotenuse. Since we have this side, which is 150 meters, we have this side. So opposite over what hypotenuse, that will be sine. So sine 45 will give us TR over what 150. Cross multiply. TR will be 150 sine 45. Press your calculator, that will give us 106 meters approximately. On the also we have a hunter walks from forest X on a bearing of 80 degrees to another forest Y, which is 40 kilometers away. From there, he went another forest Z, a distance of 50 kilometers on a bearing of 220 degrees in search for an antelope, which is short. Calculate the distance of Z from S and the bearing also. So it's very simple as well. A hunter walk from a forest X. So draw my cardinal point to represent forest X on a bearing of what, 80 kilometers. So 80 degrees rather. 80 will be here. Locate the bearing 80 degrees to another forest Y. So I have forest Y here. Then on the 40 kilometer. Then from here, it went another forest Z, 50 kilometer on a bearing of 220. Where will 224 from here? It's going to fall around here. 220 will fall around here. So I will draw 220 here because this is 180 and this is 270. 220 should fall around here. So, and that means I have the bearing from the north to this line to be 220 degrees. Then what do I have? Then this point is point Z, and this is 50 kilometers. It should be longer than this one a little. Then I will join my X to Y like that. So then we have to find the distance XZ from X. So we have to find the distance here. But before we can do that, we need an angle in the triangle. How do we get that? Very simple. So we need to get an angle here. How can we get that? We can get the remaining angle that is here. That will give us 10 degrees. Because from here to here is 90. So if this from here to here is 80, that means this one will be equal 10 degrees. So that made this angle here 10 degrees as well. Alternate angle. So if this angle is 10 degrees, and from here to here is 270. So how can we get from here to here? So that should give from we have 270 plus 10. Remove it from 270. That should give us from here to here. You know that from north to the west here is 270, and we have this place to be 10. From here to here is 220. Add 220 plus 10 together, that gives us a 230. Remove it from 270, that gives us 40 degrees. That means this angle is 40 degrees. I hope you understand that. Good. So if that is the case, you can now find this side using cosine rule as well. So if you use your cosine rule, we have this sz square equals to 50 square plus 40 square minus 2 into 50 times 40 cos 40 degrees. 2,500 plus 1,600. This time they give us 4,000 cos 40. Simplify with calculator. We have 1,035.822. Square root of this will give us 32.2 kilometers as the distance of Z from X. We have to find the bearing of Z from X. Bearing of this Z from X. Bearing of Z from X. Bearing of Z from X. That means we are looking for the angle from the north to what? To X. We are looking for the angle from this north to the X. Do I say from to the X? Well, the angle from the north to this line that join X and Z together, rather, sorry. The angle from the north to the line that join them together, that will be the bearing of Z from what? X. Then how can we get that? Very simple. From here to here is what? 80 degrees. Then if you can get whatever, everything, the angle from here to here, you can get that. That will solve our problem. If you can get the angle from this blue line to this blue line, which is the angle inside the triangle, add it to the from here to here, that will give us the bearing we are looking for. So that we can label this angle here theta. So when we label theta, we can find it using the sine rule. So when we now get it, we add it to 80, that will give us the bearing of what we are looking for. So sine rule, that will give us this side, which is 32.2 over sine 40, which is a pair. If you understand how to use sine rule, you understand what I'm trying to say. Equals to the side of angle, the side opposite the angle you are looking for, which is 50 over sine of theta, cross multiply 32.2 sine theta equals to 50 times sine 40 divided both side by 32.2. We have this. That will give us 0.9981. Find sine inverse, it give us theta to be 86.5 degrees. So now that if theta is this, then you now add it to from here to here, which is 80. that will give us from here to here as the bearing of Z from what X. So the bearing of Z, or the bearing of Z from X will be 80 plus theta, which is 86.5, and that gives us a 166.5 degrees. All right, the last question for today, hopefully, is the question that they had some, I think 2 years ago or 3 years ago. Although the question asks you have to calculate bearing, but if you can do this one, then bearing will not be a problem for you based on what you have been doing so far. You have that two boats take off from a port at the same time. The first travel at 12 km per hour on a bearing of this, and while the second travel at 18 km per hour on a bearing of this. Calculate distance apart after 3 hours. Now, if you can see that we are giving bearing and speed, and don't forget we have been working with the bearing and distance, so we are not giving the distance of that each of the boat covers. We are only giving their speed. So, and we are giving the time they both covered as well, 3 hours. So we can use that to find our distance. If you know the relation between speed, time, and distance, we know that speed is distance over time. Speed is distance over time. Our aim is to find distance. So we are given the speed, you are given time for each of the boats. So if you cross multiply, we have the distance to be equal to speed times time. Speed times time. So therefore, the distance that the boat A will cover will be the speed of the boat A, which is 12 km, times the time, which is 3. That gives us 36 km. Then also for boat B now, the distance the boat B will cover will be the speed of boat B, which is 18 km, times this time cover, which is 3. That gives us 54 km. So it is this now we are not going to use to draw the diagram. Without this, we will not be able to draw the diagram, because we are not given the distance before we are given speed. Now that we know the distance each of the boat covers, now we can now start the sketch the diagram. So the first travel on this bearing, so I can say boat A now. Okay, sorry, this is the port where they left. Both of them took off from the port. So this is the port where they took off, and boat A move on a bearing of 77 degrees. That means you have a line here, straight line here, and the distance it covers is 36 km, and the bearing is 77 degrees, and that means there will be boat A here now. So this A is standing for boat A. Then also boat B now also left this port, because they both left the same port, and his own bearing is 143 degrees. So 143 degrees will fall around here. So, and from the north to this line here, that's 143 degrees. Then this the distance cover is 54 km. That should be longer than this one. Then also the cardinal point should be here to represent point what B. Then you join A and B together. So also then you have to find the distance, calculate the distance apart. That means you have to calculate the distance between both A and both B, which is this side. And that shouldn't be a problem by now, since you should know what to do, because this angle here is 143 and this angle is 77. We need an angle inside the triangle here, and that should give us 143 minus 77, and that should give us 66 degrees. So we can now use because this triangle is a non-right angle triangle, we can use a cosine rule to find the distance between this and this now. So we have AB square to give us equals to 54 square plus 36 square minus 2 into 54 times 36 equals 66. Then if you simplify further based on what you have on the screen, this square will give us this square will give us this, multiply this, you have this. Then calculator will help you to simplify this further. We have this. Then find the square root of both sides. We have 51.3 km. So that should give us the distance between the two boats apart. And if you also find the bearing of boat A from B, or the bearing of B from A, you should be able to do that if you also do that. So I believe you have learned one or two things from this video extensively, and if you have done that and you want to evaluate yourself, you can try these 3 questions on the screen right now and see what you can do to them. If you are able to do them, please send them to me so that I can check them for you. And I want to believe that you really enjoy this video, and it has really exposed you to bearing and distance, and it has really equipped you. And if you don't truly understand, please you can go over the video again so that it will help you. And don't forget to subscribe to this channel if you are here to do that. Share the video with students out there who need these resource materials greatly. And also like the video, share the video, and comment in the comment section of the video. And as you do so, may the good Lord bless you. Bye.